So good morning, everyone. So let's get started with today's session. And today we are going to conclude RC circuit. And what we are going to today is a little bit extension of what we have done so far. The last time what we did, when the capacitor was connected to a battery, and yes, it's not possible to have a circuit without resistance. So there'll be resistance either in form of internal resistance, external resistance, or lead wire resistance. Initial charge was taken to be 0. So uncharged capacitor was connected to the battery. So today we'll try to understand what will happen if the initial charge is not 0. So let's have some value of initial charge Q. So again, what we'll do, again to solve this state here, so if initial charge is Q, again, so some charge transfer will take place until we reach a steady state. And what is the steady state? In a steady state, if this is a kind of RC and battery circuit, potential difference across the capacitor will be same as EMF of the battery, or the plate which will have connected to positive terminal will have positive charge, and the connected to negative terminal will have negative charge. So, but in between it will pass through intermediate state. Charge flow will take place. So again, let's go to where we take up some state at time t when the current is I and charge is Q. So again, I'm just going through the same thing what we have done. This equation does not change intermediate state. So we apply Kirchhoff rule. This is the relationship we start from here. If we apply Kirchhoff rule, and increase Q by C, moving against current, plus IR minus E is equal to 0, and I is equal to dQ by dt. Okay. And when we rearrange the term, and this is exactly what we had done last time. Until now, there's no change at all. So again, we can rearrange the term. So if we substitute I is equal to dQ by dt, we get this arrangement. So we bring Q to one side, and then we integrate. And that's where the change comes in. So here, their case also, we start with the initial state. Initial state, that time the charge was 0. Now the initial state charge is Q. With charge Q, is it plus Q minus Q? The charge Q is the charge on the plate connected to positive terminal of battery. Otherwise, there are two possible signs. So we are always, plate is connected. When we talk about charge, we are talking about charge on the plate connected to positive terminal. So here says Q, we don't know what the sign is. So with sign, we can substitute. And that's the only change we have so far. Initial value is different, initial state is different. And when we integrate this integration, this minus comes in here, and when we substitute, it becomes upper limit EC minus small q, lower limit EC minus capital Q. And slightly, that's the initial state, and it doesn't matter what the charge is, this equation will remain same. And when initial charge was 0, we can substitute capital Q is equal to 0. Now let's see, this is the current state. Now we'll take some specific cases to understand better. Now we'll talk in terms of some charge which is related to battery potential. Okay, so this equation, if I write in terms of this EC minus small q, and this is the charge at a time t, and this is the initial charge. Charge on the which plate, which charge is it? So we are taking charge. This is Q indicates charge on the plate connected to positive terminal of the battery. This is initial charge minus delta T by RC. So of course the time constant won't change. Now let's take a specific case. So sometimes a specific case makes you understand better. What we understand here, so we take a case when the charge on the capacitor is equal to plus 2 CE. So what does it mean? It implies this capacitor was initially connected to battery of EMF 2E. After charging, that battery was disconnected. And after this has been charged to potential of 2E, it is connected in the circuit such that the plate having positive charge is connected to positive terminal. Hence, I can write Q is equal to plus 2 EC. Okay, so this is state, and now we can substitute these values and we can find out charge as a function of time. And then we'll also see what are things we can interpret based on our logical understanding we have developed so far. So this initial state, we substitute the value of Q. So when we substitute, this becomes equal to this term here. The denominator is minus EC. And so this will become minus EC. And when we rearrange the term, this will become minus EC. When we rearrange the term here, this minus EC will go to other side and become plus EC. So this is the equation what I get. What I find here, earlier this sign was negative, now the sign has become positive. This is the equation, EC 1 plus e raised to power minus t by RC. So this explains the mathematical steps we follow to find charge as a function of time. Okay, let's try and understand here. So once we have charge as a function of time, we can also find current as a function of time by differentiating. So when I take a derivative of this, so this term will become minus, it becomes minus e by r, e raised to power minus t by rc. Why is this? Now we'll try and understand whether this whole thing makes much sense. So let's try and understand, try to interpret what this equation convey and what logical sense it makes. So first of all, when we look at what does this minus sign indicate here? Minus sign indicates we assume charge flow direction to be like this. Actually, what it says is the current flow would be in the opposite direction. Actual current will flow in this direction. So let's look at, does it make sense? So let's try and make sense of this whole thing. So even if we do not, even before we start with mathematical solution, if this is connected, one thing is certain, we can always think of what the final state will be. So when t is equal to 0, one way of interpretation is as soon as it is connected. Yes, capacitor is not a battery, but at a particular instance, we can visualize as a battery of battery having potential equal to charge by C. So it will behave like a battery of 2E. This battery E, this is the state at time t is equal to 0. So at time t is equal to 0 plus, which means soon after it is connected. When I visualize it like this, without going into mathematical derivation, very easily I can figure out at time t is equal to 0, the current will flow in this direction, and current at time t is equal to 0 will be equal to, so you can apply Kirchhoff loop rule, current will be equal to E divided by R. And when you look at this equation, and why minus sign is flowing in this direction. So here also if you substitute t is equal to 0, this term becomes equal to 1, current is equal to E by R. So what we understand, so our interpretation as interpretation of battery, interpretation of capacitor as being a battery of varying EMF at time t is equal to 0 plus equivalent to battery of EMF equal to 2E matches with the result what we obtain mathematically. So this way how the current will flow and how long this charge flow will continue is not difficult to visualize what the final state will be. We know the charge here, this plate which is connected to this initial charge was EC, final charge will come equal to EC. So what will happen? So initial charge was more than the final charge. That's why the charge will start flowing out. It makes logical sense when you look at the initial state. When we compare with what the final state has to be, we can figure out what charge flow has to take place to achieve the final state. Okay, so it's easy to visualize the final state. Yes, Akash, you have some question?
So the energy loss will completely go into heating only, right?
Then we'll come to that part also. Energy loss, of course, we need to account for all energies to put together. So is it, so first of all, let's look at, we are trying to understand what we have done mathematically. So one interpretation we can in between is mathematical, is a transient state, current will keep changing. Not possible to visualize logically, but initial state is possible to visualize. A final state also, we know what the final charge would be. So what does this mean? If this was the initial charge, this was the final charge, we know the net charge flow through the circuit is going to be EC. That is, the net charge will flow through the circuit, and the charge flowing through the battery also will be EC, which direction the battery will get charged. Rather than getting supplying energy, battery will be net recipient of charge, battery will receive net energy. Okay, so what we, in terms of the statement, is easy to visualize the final state. Capacitor will have charge so as to have same potential as the battery. That's the final state always. Okay, so this is final state. So we can think of the charge flow or current direction will depend on the initial charge and the final state charge. So since if the initial charge is less, it will increase. If it is more, it will decrease. In this particular case, initial charge was more. That's why it had to decrease. That's why the current flow was in this direction. So whenever every time we keep in mind, we are, since capacitor will have net charge 0, so we need to look at which plate are we looking at our time. We are looking at, when we talk about charge flow, let's focus on the plate of the capacitor which is connected to positive terminal. So we are not looking at other one, we are just concentrating on which plate, the plate which is connected to positive terminal, which makes our interpretation easy. Okay, so this is what the expression will come to, and from here is easy to interpret. Yes, since if our derivation is right, if I substitute at t is equal to 0, this charge value should come equal to 2 EC, and at t is equal to infinity, this should come equal to plus EC. Does it happen? Yes, it happens. When it comes to t is equal to 0, this becomes 1. So 1 plus 1, that's why there's a plus sign here. 1 plus 1, it becomes 2 EC, and t tends to infinity, this goes in the denominator, this whole term becomes 0 is equal to EC. And that's how the current flow will be. And current also will be current will be maximum initially and keep declining till it reaches 0. It's exponential decay curve. And negative sign indicates opposite direction. Just to get a better understanding, initial charge to be EC and positive plate was connected to the capacitor having positive plate, capacitor plate having positive charge was connected to positive terminal. What would happen if we make the connection in a different way? Okay, Ahlal.
Sir, in this case, the battery doesn't get charged as in the previous case. All the
Yes,
power
yes, of
goes
course,
to the
battery will get charged. Battery energy will increase. See, whenever the charge flows in this direction, it means battery is it is receiving energy. See,
Sir,
if
actually, like if we see, I mean, if we see Q by C and IR, they will add up to be E only. So potential
let's see, we'll come
battery
to
will be
that part
positive.
also. But you see, battery. See, whenever I think that part is there cannot be any two ways. This there cannot be any, should not be any confusion. So whenever battery is like this, whenever charge flows from here to here, is potential energy is increasing. Where from the increase of potential energy coming, battery is supplying energy. So whenever charge flows or current flows from negative terminal to positive terminal, always energy is supplied by the battery. And so battery is getting discharged. This is normal state, this is discharge state, and this is something, there's no exception. Other case, what happens? Other case is something when charge or current, both have same meaning. If charge or current is flowing in the other direction, in this case, battery is receiving energy, we can call it, or I can also call battery is getting charged. In this case, I think this should not have any doubt. In this particular case, it is moving in this direction. I could have done here also what is potential energy is decreasing. Potential energy charge, when it moves from high potential to low potential energy is decreasing. Where is the potential energy going? Potential energy, loss of potential energy is being stored in the battery. Okay, and we look at some numerical values also. I think we balance what is happening. I think one case we look at, first we'll understand how the current flow will take place, what the current will be, what final charge would be, and then finally we look at energy balance. Okay, so coming to the second part here, this case, what is the difference here compared to previous case? If I have state in part of words, what do you interpret this figure as? This figure indicates moment I write charge is minus 2 EC. It indicates battery, this capacitor has been charged to potential E. What is the charge? It is charged with, this must have been charged with battery of EMF 2E. So this is charged with battery of EMF 2E. And after that, battery is disconnected. It has certain charge. But unlike previous cases, now the plate having negative charge is connected to positive terminal of the battery. And if I go by normal sign convention, okay, so Q is equal to 2 EC, that's the charge by battery of TMF. But if I have to take initial charge Q, would I take as plus 2 EC or minus 2 EC? If I follow normal convention, I will change initial charge as not 2 EC, I will change. This case is not same as previous case. So this initial charge Q, if I define charge Q as the charge on the plate of the capacitor connected to positive terminal, it has to be equal to minus 2 EC. So when I make this substitution, I will not substitute plus 2 EC, I substitute minus 2 EC. It's simple sign convention, should not have any dispute. So when I substitute this value, it comes like this. It becomes equal to EC plus 2 EC. And when I rearrange the term, it comes equal to EC 1 minus 3. This becomes 3 term, it goes here. And when we shift both to either side, becomes 3 EC. Again, we check just to make sure that our
Sir, I didn't understand why you took minus 2 EC.
What is the initial charge? See, this charge, One plate has charge plus Q, another plate has charge minus Q. So should I take net charge on the capacitor, or should I take charge on one particular plate, or I can take any sign? Tell me. Okay. When we write this sign, this is something, when we write this equation also, when we derive this equation, how do we, why did we write this QC? Because this is something, it was assumed to be, this whole derivation was based on this. Okay, this sign has importance. Yeah, so this having plus Q charge and this having plus Q charge, they are not same. So what is the sign convention we have followed? I think mentioned a couple of times, I have mentioned here also. What is Asha, what did I mention? What is the left initial charge on the plate connected to positive terminal? Because this initial charge, this capacitor is connected in this fashion, positive charge plate connected to positive terminal battery, this situation is not same as negative charge. Are these two identical? They are not identical. In previous case, yes. In this case, what will happen? Final state, what will happen? This is minus 2 EC. So what is Q defined as? I'll repeat again, and that is something should be understood. What is Q? Q is defined, we have to use the sign convention.
Okay, charge connected to positive plate.
Not identical, and it is not difficult to understand. The final charge, can this plate have negative charge finally? No. This finally it has to have charge EC. Charge EC, but one plate will have positive, one will have negative. Which will have final EC charge? This will have positive charge.
This will have positive and the other one.
So from here it is changing from minus 2 to EC to plus EC. The charge flow is 3 EC. So both are not identical, and this is not difficult to figure out. Just pay attention, you will know that. Okay, so Q is equal to minus 2 EC. How is charge defined as? When I substitute key, again I repeat, what is this Q? Q is the initial charge on the plate of the capacitor connected to positive terminal. Here written in the statement also, let's understand that part. Okay, and that is minus 2 EC. And that's how we get to both situations are not identical. Hence, substitution is not identical. Hence, the final equation is not identical. So if we interchange the terminals, does it lead to the same result? No, it will not lead to the same result. Logically, it doesn't make sense, and mathematically doesn't make sense. How do we handle mathematically? The sign has to change here, and the final also sign will change. Okay, so this result, so let's again check at t is equal to 0. What is the at t is equal to 0, what is the value we get? T is equal to 0. When you substitute t is equal to 0, power becomes 0. Power of 0, anything becomes 1. So at t is equal to 0, this term equals to minus 3, and this is 1. So what is the charge at t is equal to 0? Now it comes equal to minus 2 EC, which is what it is. I'm just checking this. Are we getting the result which is in harmony with problem what we have on hand? What will happen at t at infinity? At t into infinity, this term becomes 0. T is equal to 0, this term becomes 1. T equal to infinity, it becomes 1 by e raised to power infinity. So this becomes 0. 1 by infinity is 0. It becomes equal to Q is equal to EC. So which I again check, I feel this equation, at least at the initial state and final state, it matches with the physical reality. And what would I be here? I in this case again, if I differentiate it again, I will be plus or minus. I term will again come equal to.
So it should be plus, right, sir?
It should be plus. Differentiating, this minus sign is already there. So which direction will the current? Does it match? That should come as plus 3. Which direction will the current flow? If initial current is less than the final value, it means charge has to flow into the positive plate. So which direction? This is the direction of current flow. So does it make sense? Yes, when it is minus, this also minus. When it differentiate, it has to become plus. This is a plus sign. And what is the initial current? Initial current T is equal to 0 is 3 by R. Does it match with this case here? So if I have to visualize how net charge flow till steady state is reached. So what will the net charge? What is the net charge flow? Initially it was minus 2 EC. We keep adding. How much charge has been transferred to from this side to this side? What is the total charge transfer in this case? Pranav Soma, can you tell me what is the total charge transfer in this particular case? How much charge will flow through the circuit here? Initial charge was minus 2 EC. Final charge has become EC. Pranav, what is the charge flow? Net charge transfer.
Is it minus EC?
Huh?
Is it
any quantity, if it is from -2, it has become 1. What is the change in that quantity? What is the increase in the quantity, Pranav? From -2 to 1. Is
Yeah,
it
it
not?
increased by 2.
-2 to 1 increases to
1.
1. So if I plot what is the number line, I think you have to start teaching a number line. This is 0. This is -1. This
The
minus
change is 2, sir.
changes
2.
2. Changes from here to here. Change is 3. -2 to 1, change is 3. Okay. So what is the charge flow? Charge flow will be equal to 3 EC.
Yes, sir.
Okay.
Yes.
So, yeah, it doesn't happen. Sometimes our mind goes blank. So I know that one. So this is what will happen during the entire process. Net charge flow till it reaches steady state. So I understand this was the initial state. The charge was equal to -2 EC. It has become 2 EC. It means how much charge has been from here. Charge has been subtracted and it has been added here. What is the net Q? Net Q is equal to final charge minus the initial charge. Final charge minus the initial charge. If I use a simple formula also, it comes equal to 3 EC. So in terms of this is the charge flow which will take place. Now, there are few things we can calculate now. What is the energy? Is the battery supplying energy or receiving energy in this particular case? Supplying energy. So in this case, energy is supplied by the battery. So if I look at
charge
the
supplied
energy,
is 3 EC.
so per charge transfer is 3 EC. The Q is equal to 3 EC into E. So net energy supplied by the battery will be equal to delta Q into E.
3 E square C.
So 3E square C. That's the energy supplied by the battery. Okay, now let's see where all this energy could have gone. Okay, sorry, I didn't press that. What is the change in potential energy of the capacitor? Now, some energy, see, basically something energy supplied, something could be change in potential energy. What is change in potential energy of capacitor?
1 by 2 3 E square C.
So I'll use the formula Q square by 2C because I know the charge, I know the value of CC is not changing. The change in potential energy will be equal to final Q square minus initial Q square divided by 2C. So what is final charge? Final charge is E square C square. So it will come in form of E square C square. Final is 1. And initial one was how much? 4. So what has happened? Actually, potential energy has rather than increasing, it has decreased. What is the decrease in potential energy?
3 by 2 E square.
Okay. So what about, so total, whatever energy has been supplied, we have to account for. So this is what is energy supply in any equation. Energy supply has to be equal to what? So this has to go either energy supplied by battery, as per our understanding, it should be split into two parts. There are only two things it can go to. Which are the place it can go to? Increase supply can go to increase in potential energy or change in, or it should go into heat. But rather than increase, this is negative. So E has to be energy supplied by the battery has to be equal to delta PE
9 E square C by 2
plus heat energy, heat dissipated. So what has heat dissipated? So if I just simply put these values here, what is the heat supplied by the battery? 3 E square C is equal to what is change in potential energy? Minus 3 E square C by 2 plus heat dissipated. So what do I get as heat dissipated as? 9 E square C by 2. So do I believe this number or is there some way I can check this quantity? Ahlad, can we check this quantity heat dissipated in some manner? Can we have some mathematical relationship? Can I check this heat dissipated in some other formula which is there on the screen?
I square.
Perfect. Now, so what we can do, heat dissipated, one is I have arrived from energy balance. I can check this value as, okay, heat dissipated, I know the value of current at each instance of time. I can calculate heat dissipated as this. Heat dissipated is I square as a function of T, I square R dt, from where to where? From 0 to infinity. So if this I term is here, I can take it as square and all of you can check it also. When you add it up, it will come to the same value. So this is how we have energy balance. What is our understanding? Again, to repeat, what is energy balance here? Energy balance is heat supplied by the battery, or energy supplied by battery, which makes logical sense. Energy supplied by battery is equal to what? And it could be positive. Each one can be positive or negative. It can be negative also. Heat supplied by battery is equal to delta PE plus heat. Out of 3 terms, 2 of them can be positive or negative. 1 term cannot be negative. Okay. Now, Shweta, have you understood this equation? No response.
Yes, sir.
Have you understood this equation? When is heat supplied by battery is positive, when it is negative? Do you know that? No idea. When is the heat supplied by battery is positive? Can it be positive or can it be negative as well? Shreya, can heat supplied be positive as well as negative, or it is always positive? Sorry, energy supplied by battery, can it is always positive or it can be negative as well? Okay, Tejas.
I'm not that sure, sir. But
Not that sure.
yeah.
Ahlad?
It can be both.
It can be both. When is heat supply, energy supplied by battery is positive?
When it is connected in the same orientation.
So when the charge flow takes place in this direction, energy supplied by battery is positive.
Understood.
What happens and when charge flows in this direction, then it is, when it's flowing from positive to negative, that's called charging state.
Yes, sir. Charging.
And so sometimes we forget, and that's why I think we need to keep refreshing what we have learned. So in this case, this could be positive or negative. How about change in potential energy? This also can be positive or negative. How do we determine? So we have understood sign of energy supplied by battery can be positive or negative depending on which direction the charge flow takes place. If the charge flow is from negative to positive, this term is positive. Charge flow is from positive to negative, this term is negative. Similar way, how do I define when would delta PE be positive, when would delta PE be negative? Preetham, can you tell me when would delta PE be positive, when is delta P is negative? We are talking delta P is potential energy stored in the capacitor. When would this be positive, when would this be negative? Preetham. And I'll tell you answer is fairly simple. What is potential energy? In this case, all this case, capacitance is not changing, charge is changing. So potential energy is Q square by 2C. It depends not on the sign, it depends on the magnitude of charge. If magnitude of charge is increasing, potential energy will increase. If magnitude of charge is decreasing, potential energy will decrease. Is this something which need to be written down or memorized? Absolutely not. This is something I think once we know what is energy stored Q square by 2C, we should easily, our mind should be easily able to interpret when the value of magnitude of Q, if charge magnitude increases, potential energy increases. If charge magnitude on the capacitor decreases, potential energy will decrease. Heat term will always be positive. This cannot be negative. So this could be positive, negative. This could be positive, negative. This is always positive. All right. And okay. Let's take one more case here. In this case, what is the substitution we'll make here? This is what potential it is charged to Asha. Yes, what question you have? Yes, anybody? Asha, you raise your hand.
Sir, that was by mistake.
That okay. No. So let's come to this case here. If suppose it is connected like this, in words, how would I have written this particular case? Asha, can you tell me how I would write in words? How would this battery? Suppose this question is given in words. How would this be worded?
It's a capacitor charged to a charged by a battery of EMF E by 2.
No, it is charged by battery of EMF E by 2. And how it is connected?
The positive charge is connected to the positive terminal.
But the plate having positive charge of the capacitor is connected to positive terminal. That's why I will take this value of Q to be positive. So what I'll substitute in place of Q? I'll substitute Q is equal to plus EC by 2. Okay, charge by battery of EMF E by 2. Okay. So this negative sign, that's why it will remain EC minus EC by 2. And again, I can find an expression. This expression I get. So finding this expression is, we can, once we know any charge, any initial charge, we can find the value of charge and as a function of time. We can also find current as a function of time. We can do so. Current is what? Current is, okay, sorry, this time also maybe I think we have not copied. This also has to be plus. Whenever this is minus, when differentiate, this another minus sign comes, it becomes plus. So this also is a charge. So again, are we clear about this part? So again, this is t is equal to 0. This is how we'll visualize. And we could have thought of current direction. How would you can think of current direction? This is EC by 2. And final charge, this also is equal to plus EC. What has to happen? The charge has to increase. It means the current has to flow in this direction. So far, is this understood? And typically connecting a charge capacitor, I would say it falls not under very important topic. Mains level, normally they don't ask such question, but still I think these are not so difficult. If you can understand, it's good. But if you understood till yesterday, if you are having little difficulty following what we are doing today, that is not too much of a problem. At least what we did till yesterday should be understood. That is mandatory part. This is something I would still say it falls into optional category. If understood, much better. If not understood, not a reason to worry too much.
Sir?
Yes.
So in the previous case, energy supplied will be positive, right?
Case, in this particular case?
Yes.
Yes, of course. If this is direction of current, how it is flowing in this direction. Charge flows in this direction.
Yes.
Whenever charge flows, how much charge flow will take place in this case also. If I have to write what is the energy supplied by battery, positive. How much that will be charge flow? What is the charge flow? From EC by 2, it has become EC. Final charge minus initial charge. It will be equal to charge flow is EC by 2 into E. That's the energy supplied by battery. Nitya, your video is on. I think it's set it up. I think we didn't realize. Nitya, this is energy supplied by battery. And what is change in potential energy? From initial charge EC by 2, charge has increased. Of course, potential delta P will be positive. How much delta P will be equal to? Delta P will be equal to 1 by 2C. Final charge minus initial charge. And then can we calculate heat dissipated? Yes, now we can calculate heat dissipated. Yes, Akash?
Sir, here while deriving, we just took current as dq by dt, right?
Yes.
We didn't know the direction of the current.
No, see, see, again, go back to initial derivation. See, what we did, but this is something we assumed this charge to be Q. We started with this charge to be Q. And we took this as a positive. And we took this as a charge. So, and so if this is negative, what has to happen? But this is something, this is what we took as positive, initial derivation. Look at that initial derivation. Look at the sheet. So understanding sign and purpose behind it also has to be clear. And in this particular case, as we are charging dq by dt, but this is the convention we have taken. And so whenever this charge is positive, initial one, we substitute a positive value. When it is negative, we substitute as a negative value.
Sir, your voice is breaking silence here.
Okay. So just go back to initial derivation and see that it is matching with all those things.
Your voice is breaking silence.
Even now also?
No, sir, it's clear only.
It's clear for me, sir.
Okay. So, okay. Sometimes it happens. Yes, internet connection. Okay, go back, Akash. Go back and look at the derivation again, and see that what sign convention has been followed in derivation. And I have stated sign convention. What is the sign convention? Sign convention, we have taken this direction, current flowing into the positive plate as positive, and the charge on this plate as positive. That's the sign convention we have taken.
So it automatically adjusts itself, right?
Correct.
Like we'll get negative.
Yes.
Then why didn't same thing happen while charging a while discharging a capacitor? Sir?
That is different derivation in case of discharging.
Minus dq by dt.
Then there we are taking a different day. Just look at the sign convention there also. See, when we take sign convention, but there also what is happening is they are taking slightly different convention there. There was a discharging always. There was no question of either side. In case of discharging, flow, direction of flow is always in one direction. Go through that again and see that where is the difficulty in derivation.
Okay, sir.
And see that you understood. Now this is, see, how do I find the sign of, I have mentioned earlier also yesterday. Whenever you have some equation relationship between any two variables, what does any such equation indicate? It indicates a relationship between two physical quantities varying by small amount. When would the relationship will have plus value? When it would have relation value, negative value?
And both in
yes, both move in the same direction, plus and minus. So that's one way to think of it. Okay. Now let's look at this. Now finding time constant. So this is what I have done so far. What again a little advanced topic, which is capacitor which is connected had initial charge. Now we come to second part where it is connected like this. It is not one resistance, it is connected like this. In such case, by known whatever knowledge we have gained so far, it is not easy to find time constant. Okay, so in this particular case, see there are two situations given. Find time constants when switch is closed and charging. When switch is closed and charging, you will have a different circuit. What is the circuit? This is the circuit. This is closed. So in that case, there will be current here as well, and there will be current here as well. So current is flowing through this resistance, current flowing through this resistance, and battery is getting charged. After a long time, when the switch is opened, after keeping it closed for a long time, when this switch is opened, now the current in this will stop flowing. Current will flow only in this part. Which part? Only the circuit will be only top half. So both cases, the circuit changes and hence the time constant also changes. We'll have certain value of time constant while charging, and we'll have a different value of time constant when it is open, discharging. Let's understand how do we calculate time constant. I'm not going through basic derivation. If some of you are interested, I can tell you later on what basic derivation is. It comes from same Kirchhoff law. But in terms of simple rule, we can define how we find time constant. When we find time constant will always have an R term and C term. C is clear. C is only one. Confusion is about what R should be taken.
Yes, sir.
Let's define. I have to take some R equivalent. What is that R equivalent I should take? So that's a definition I can use to define R equivalent. Equivalent resistance between terminals of the capacitor after shorting the battery. This is something, do we have a proof? We don't have a proof, but this is something what you need to remember. This is how we find R equivalent when a circuit is complex having multiple resistance. Now let's do in this case. Second case is simple. There's only one resistance. In this case, what is the value of R effective? This 10 ohms only. So when which are the 2 points? So let's leave that one. So whenever we find resistance, we have to define between 2 points. Which are the 2 points? 2 points terminals of the battery. So actually battery is connected. If I call this point as A and this point as B. So where is the capacitor connected? Between A and B. So I have to find the equivalent resistance between point A and B after shorting the battery. So what I do, this battery, I replace the battery, I can make a direct connector combination. So this becomes my circuit. What is the resistance between A and B now? Can we find resistance between 2 point A and B? Okay, let me ask Karthike, can you tell me what is the resistance between point
So why did we remove the battery, sir?
Just now I told, this is a rule.
Oh, it's a rule.
You can find a proof, but yes, it's a lengthy process. It is just what, that's why again I repeated, are we giving a proof? We are not giving a proof. What is the method we follow? Equivalent resistance between terminals. What is RE? See, first point again, let me repeat. To calculate time constant, I need R value, I need C value. C value, there's no dispute, there's only one capacitor. Problem comes with the resistance here. The current is flowing in both the resistance. So which resistance should I take and how should I account for this? If I call this R1 and this R2. How do I find? Method is, this is like a rule. Equivalent resistance between terminals of the capacitor. Which are the 2 points which are terminals? So this is saying capacitor is connected between point A and B. I have to find equivalent resistance between point A and B. There's a battery. When we find equivalent resistance, we find equivalent resistance for a circuit which has only resistances. Since there's a battery, what we do, we short the battery. We remove the battery by a conducting wire. Now it becomes easy if between A and B, these two are connected in parallel. So equivalent resistance becomes equal to 5 ohms. So what will be the time constant for this circuit? The first case, it will become equal to R by 2. So time constant will become equal to R effective. For here, R effective will be R equal. It will be equal to 10 by 2 into 25. How about this circuit? This circuit, there's no problem. This circuit, there's only one resistance connected. This is, once we open it, this is out of the circuit anyway. And you know, okay. So what is the, in this case, so second case, what is the effective resistance? 10 ohm. The charging state will be R. Tau will be equal to 10 into 25. So time constant first case is different. And so what it is, this is equivalent to finding equivalent resistance, nothing else. So how should mentally think? How do you should mentally think finding time constant? Mentally you should think time constant is equivalent to finding equivalent resistance. How do I find equivalent resistance? For equivalent resistance, I have to define two points. Which are the 2 points? 2 points are points across which capacitor is connected. That's what you need to follow. And any circuit, we can find time constant.
Sir?
Yes?
Sir, we short the battery for ease of calculation.
It's for calculation purpose only. And if you want to find time constant, you can derive also. If you want to understand, I can tell you method of derivation.
Give the basic method.
Yeah, basic method. It's the same Kirchhoff rule. See, basically, what would Q be? Again, I write this Q here. But there also I've written dq by dt is equal to I. Here I have to write dq by dt is not I. What will be dq by dt? It will be equal to I2. Okay. But there also, when I wrote a Kirchhoff loop rule, so I have to write one more equation. There I used Kirchhoff loop. When I apply Kirchhoff loop rule, suppose I take this loop here. So Kirchhoff loop rule, when I apply here, this current is I1 plus I2. So what happened? I have I1 and I2 both. So how do I get rid of one? I have to, using other loop, I have to eliminate one of the I. Even I1 also to be written in form of I1. Sorry, I1 to be written in form of I2. Then we get same equation, we integrate, we get an answer. So only thing what we get here, in previous case, how do you find time constant? I get an exponential form. It was coming like this. When I do something like this, in this case, I find it comes something like this, minus t divided by R1, R2 divided by R1 plus R2. So how do I interpret, okay, this result is coming because this could be taken as parallel. That's a kind of derivation. And this derivation is called Thevenin's principle. This is normally taught in engineering courses. Okay, and not necessary here. But since it is a simple step, no harm is knowing, especially because one question has come in the past in JEE Advanced, I think 4, 5, 6 years back. Mains till date, no question has come. But since the question has come in advance, mains also what they tend to do, something which has come in advance, they also include those questions. So that's why we are teaching this topic, and it actually is only one sentence. If you understand one sentence, it is equivalent to finding equivalent resistance, nothing more. So is this statement difficult to interpret and understand?
No, sir.
No. And we do some questions, you'll get a hang of it. It is just finding. So finding time constant in a complex circuit is equivalent to finding equivalent resistance. All equivalent resistance, you have to define which 2 points. Here, which 2 points are defined? The points across which capacitor is connected. What happens if there's a battery? Oh, remove the battery and short it. Finish. Okay, now again come to some basic derivation. So these questions also, I think they are little things. Typically, mains level questions are not up to this level, but it's still okay. So this also, I would believe, to be an optional topic. A capacitor or capacitance C is given charge Q. At t equal to 0 is connected to uncharged capacitor equal capacitance to resistance R. Find the charge on the second capacitor as a function of time. So this is initial state given. So do you think this finding a solution for this is very similar to our initial derivation? Okay. So here also what we do, initial charge is Q. So what will happen at some intermediate state where charge will get in transferred. So some intermediate, it will start getting some charge here. It will start this plate, the plate which is connected to positive terminal capacitor. Let's say at some state this has distributed charge Q here. And at that particular instance, the current is I. Okay, remove that one. I think this while copying it has come. This current is I. Can I write an equation now applying Kirchhoff loop?
Yes, sir.
If the current has come I, from where from this current has this charge has come? Will the charge, if the initial charge was Q, will this charge remain same?
Q minus Q.
Q minus Q.
So only thing what happens when I write this equation, this will become Q minus Q. Now it's easy to write the apply Kirchhoff loop rule. Let's write this equation. Okay, this is the shape. Okay, sorry. Okay, so this was the I was coming because of this. So this will become plus Q minus Q, and this is state. Can I write equation now? Easy. So start from here. Increase Q by C, and moving against the direction of current minus IR. Minus only thing what happened there, the battery potential was coming. Here this is another capacitor, but I am now going from positive to negative, hence the negative sign. Negative minus Q by C by 2. And what is current? I is equal to dQ by dt. So this is a simple differential equation. So if I rearrange this term and integrate, this is the solution I get here. All of you can try. This is a very simple integration. You just rearrange the terms and integrate. And what is the initial values? Initial value, what will be the initial value here? Q. What will the limits of integration?
Till Q by 2, sir.
No. See, limits of integration. When we integrate, we start from known value to unknown value. Value is charge on this value of Q is known at time t is equal to 0. What is the value of Q at time t is equal to
0?
0
The limit will be from 0 to small q, and time will be 0 to t. So this is something I think all of you can do this integration on your own, and it's very simple integration, very similar to previous one. And let's try and understand what are this. Does it make any sense? And when I look at this also, whenever I look at the charge, I check at two things. At what is t is equal to 0? What is the charge at t is equal to 0? At t is equal to 0, this exponent form, this becomes equal to 1. This t becomes 0, e to power 0. E to power 0 is equal to 1, charge is equal to 0, which makes sense. What will happen t is equal to infinity? When t is equal to infinity, this term becomes 0, small q is equal to q by 2, which also makes logical sense. What will happen? Okay, the charge will get equally distributed. This also will have q by 2, this also will have q by 2. Both will have same potential difference. Potential difference across this capacitor and this two capacitors has to be equal. We find current also as a function of time. And you know what is the time constant here? If I look at this equation, Disha, can you tell me what is the time constant in this equation?
RC by 2.
RC by 2. Does it make sense? So what has happened? R term has remained same. C has become C by 2. Why it has become C by 2?
Was two capacitors.
Two capacitors connected in series is C by 2. So it makes some logical sense, and we can derive also, and the current value come like this. Current also, this is negative, and differentiate is positive. Yes, this is the direction of current, and current will charge transfer will have an exponential decay. The current also will decrease exponentially with time. What is time constant? RC by 2. Okay, let's look at some more questions. So in terms of theory, all complete. I think we're done. And okay, let me do one more thing here. Just doesn't move. Suppose I frame another question now. What is the question? There is a capacitor. There is a radius r, a conducting sphere, and there's another conductor sphere of radius r. And let's say what will the capacitance of a sphere? What is C value? Anyone remembers? What is the capacitance of a sphere of radius r?
4 pi epsilon.
4 pi epsilon.
So let's say this also is capacitance C. This also is capacitance C. If this has a charge plus Q, what will happen? We connect by a wire. Yes, charge transfer takes place. And you all remember when we connect by wire, finally this also will be Q by 2, this also will be Q by 2. When you connect a wire, wire has to have some resistance. This resistance is R. As the charge transfer takes place, there will be some current flowing here. How would this current flow be in this particular case? Can we find an expression of current as a function of time? And think for a while, this case and this case are exactly the same. Both are exactly the same. Okay, so what I would write here at time t, on this charge is q minus q small q. On this charge is q. And this point is A and this point is B. So what is the equation I'll write? VA, I could have written this is VA minus IR is equal to VB. And what is I equal to? dq by dt. What is VA equal to? What is the potential at A when the capacitance is C, charge is Q minus C? VA will be equal to charge on A divided by its capacitance minus R dq by dt. Yes, Shravani. Huh?
Sir, nothing, sir.
Okay, nothing. Okay, good. So what is VB? VB is Q by C. So could I have written this equation? Grishma? Gayatri?
Yes, sir.
Is it anything going into the head or going over the head?
No, sir, it's going into my head.
No, you understood this part also? How we are written? Here it is not forming a loop. But still, can we not write an equation? Yes, there's a potential. This, if the current is flowing, why is the current flowing? The potential is A is greater than potential at B. And I can use that condition. Or I could have written what is I equal to potential difference by, I could have written VA minus VB by R, which is same as this. And what is potential at A? It is a capacitor. So charge by capacitance is equal to potential. And is this equation and this equation same? Okay, so let's look at some more. After this, I have added some exercise questions, which is part of assignment today. Okay, and some of things I will discuss now, and some of the things we can do in work session. All these questions, there are 5-6 questions. We'll try to finish those questions today. Some of it we'll do now. But okay, maybe one more question we can do now, and rest of it we'll do in. Maybe you can do in work session or you can do on your own. Let's first read this question and try to solve it now. So we need to find, this question is asking what is the time constant when switch is open after it has been charged. So this had some positive charge and let's start flowing. What was the time constant? How do you find time constant here? The time constant will be equal to, so when this switch is open, this is not part of the circuit anyway. Okay.
5 milliseconds.
So this is a one type of, see, this is at A and B. What is the effective resistance between A and B? Both resistors are connected between A and B. Both are in parallel. So R effective will be equal to 1 kilo ohms by 2 into C. So that will be equal to 0.5 kilo ohm into 100. Suppose I extend this question, what is the time constant while charging? When it was getting charged, can you calculate what is the time constant when charging? When switch is closed, will it be same or different?
R by 3C.
While charging. While charging also pretty simple. All we'll do now, this is closed and battery also will connect like this. Again, what is the resistance between A and B? All three are in parallel even now. This resistance also connected between, see, this is all these points are at the same. We have to find equal distance between two. This is all points are potential A. So when the circuit is, when it is charging, if switch is closed. And all these points in battery is shorted. All these points are at potential B. All three are in. Which 2 points I have to find? These 2 points A and B. All three in parallel. So while charging, what has to be value of R effective? R effective is 1 kilo ohm divided by 3. So time constant while charging will be equal to this R effective and 100 into this answer. Kathy,
Sir.
anything going into your head?
Yes, sir.
Okay, good. So have you understood this question pretty well?
Yes, sir.
And so any such similar questions should not be a problem. So moment we talk about time constant, if there are multiple resistance is equivalent to finding a equivalent resistance. And those circuits may not be too complicated. All we need to do, I hope you understood, difference between switch open and switch closed, and what do we do with the battery. Battery, we can forget battery, we can just connect by a conducting wire, and it's simple. So both cases we can find out time constant. Let's take this case here. This is a little different. This is not time constant, slight variation of what we have learned so far. So do we know, can we find this current I1 and I2, or is not possible from based on what we know so far? If this current is I1 and this current is I2. Suppose I draw another circuit. If this circuit current is I, you think this current I will be identical to I1 at all instances or not?
Yes, sir.
Why?
Because while dq by dt will be equal to I1 and
basically when you look at this, what is the voltage available to this combination of capacitor and resistor? It is equal to V. It has got nothing to do. So per charging of capacitor C1, when it is connected across battery and there's no resistance here. Okay, so these two and this circuit is identical. So this I will be identical to this one. So what is I1 here? If I have to write charge on Q1 or I have to write I1, what is I1 normally equal to, or equal to? I1 is equal to I0, which is V by R into raised power T by RC. So in this case also, what could I written? This is equal to EMF available all the time is V. So V divided by R into e raised to power minus T by RC1. And if RC1 is equal to 2C, you can write as V by R e raised to power minus T by.
be constant, right, at all time.
Hey, let's look at that. So this is I1. First, have you understood this point?
Yes.
Can we similar way, can we write I2 as well? Let me see, are we out of time? Or, yeah, I think, can we, I'll just continue very quickly, I'll write. What is I2 similar fashion? I2 will equal to V by
R, e power minus T by
RC. What we need to find I1 by I2 ratio. What will be I1 by I2 ratio? I1 by I2 ratio will be equal to e raised to power minus T by 2 RC divided by e raised to power minus T by RC. What will be equal to e raised to power T by RC minus T by 2 RC. What is equal to e raised to power minus T by 2 RC? How is this function? Is it constant or decreasing with time, increasing with time? Anything e raised to power minus x can occur. This is decreasing with time. No, it's clear. Sorry, what I've written. This is plus. No, so this will keep increasing with time. Ratio will keep increasing with time. Okay, I think we are out of time. So we'll continue. So I'll send this sheet. So remaining problems in the sheet are assignment for today. There are 3, 4, 5 questions, and we should try and finish. And most question we'll try and cover in the work session itself. Okay. I'll end the session here. Time for your next session. Okay. Thanks, everyone.
Thank you, sir.
Okay.
Thank you, sir.
Thanks, everyone.
Thank you, sir.
Thank you.
Yeah.
Thank you.